Chapter 7 reviewed several types of validation. From strongest to weakest, they are exact match validation, such as gender. Known good validation, where we know a good pattern, such as an email pattern or a phone number pattern. And then finally, known bad validation, in which you have a list of what not to accept. So in this lab, we're going to use regular expressions to decide if text input follows the blacklist or the known bad validation. Before you start, review the SQL select statement if you do not already know how that works. So SQL stands for Structured Query Language, and it is the language you use to access data from a database. I've also posted a few videos on creating regular expression patterns. So regular expression patterns take some work in deciphering how to do that. There is a regular expression class in C# and in most languages, JavaScript, Java, that has a method called match or isMatch that will tell you whether your string input is a match to the regular expression. So here's a URL for C# regular expressions. And there is a hyperlink to this PDF file on that page that shows you all the patterns that you can use for your regular expressions. We'll get more to that later. Let's take a look at what SQL injection actually is and some of the characters we do not want, the bad characters you do not want, and why. Here is a select statement that you might execute if you had a login page with a user text box and a password text box. Let's say that the user entered Bonnie for the username and Zebra for the password. And so what this select statement is doing is seeing if there's a record, and it's going to pull the account number if there is a record. So let me go over the select clause a little bit. So select is followed by the fields that you want to retrieve from the table. The from clause lists the table. And there can be one or more tables here. We're just pulling from the users table. And the where clause is the criteria that's true or false. It's kind of like an if statement. So this would be almost like if username equals Bonnie and password equals Zebra, pull that record. But you don't have to write the source code. You just need to write the SQL to do that with a database. Of course, when you're writing your code, you're not going to hard code Bonnie or Zebra, or everybody will be Bonnie or Zebra. You need to retrieve those values from your text boxes on your login form. So then the code becomes some string concatenation, where you're concatenating the string literal select account number from users where username equals, and then you're concatenating that with the variable that you have stored the username in. Notice the format of string concatenation. Because Bonnie had to have quotes around it, and yet when it becomes a string variable, it needs quotes around it. What we're going to do is we're going to substitute these double quotes around Bonnie, or whatever the username is, with single quotes. This double quote terminates this literal. The single quote will be there. The plus sign is the concatenation operator. It's a string operation. By the way, that's known as an overloaded operator because you know the plus sign for numeric operations also mean addition. So now we're saying, well, plop in the username here, and let's go back to concatenate the rest of the string literal and password equals, and again, the single quote password. Okay, so this is our statement. Now let's take a look at what might happen if the user entered something like this, strange password. But let's say we're not knowing anything about security. We're going to allow the user to try to enter that. And in this case, the password can literally be anything in the world because the injection is going to happen. So what's going to happen is this string, okay, is the username. So I've just plopped this string, the username, right here. I haven't completely done the full concatenation. I'm just showing you what if we plopped that there. And password could be anything in the world, okay? Step 2, I'm going to concatenate. So the select statement now looks like select account number from user, where username equals nothing, okay? Or 1 equals 1. And then we've got the dash dash, which happens to be SQL's comment characters. So anything after dash dash and afterward gets to be ignored. And that's why password could be anything in the world. So when this executes, username equals nothing or 1 equals 1. Well, 1 always equals 1. So this is a true statement. So it's going to look at a record and it says the username equal nothing. No. Does 1 equal 1? Yes. Oh, that's true. And every single record is going to come up true. And guess what your hacker just got? The list of all account numbers. So that is SQL injection. Now, there are other ways to write this code, but I've written similar code many times to this. But there are parameterized queries and stored procedures. Database programmer will write the stored procedures. But parameterized queries is very common also, and it's going to help you avoid maybe this type of error. So I went to the Microsoft site, and these are the characters that should not be in username if you want to avoid SQL injection, like the example shown above. So what you're going to do is you're going to create a program that's going to send an error message if the user tries to enter any of these characters. Not all of them, just any of the characters anywhere in the string. And I want you to do a regular expression to do that. This website's called regex101.com. And if you'd like, you can try to build your regular expression here. The video I referenced uses this site to help explain how regular expressions work. I would start by adding this flag called global. And let's just add a pattern here. And I suggest that you review how to create patterns that will test if one of those characters that you should not have is in your expression. So I have entered the regular expression that's going to test for any of those characters being in a string into the regular expression box, which I'm not showing because I want you to come up with this regular expression. And one of the characters you can't have is a semicolon. If there's a match, if you've watched the video, you will see that it will display a green highlight by that character. So one is a semicolon. Is there a semicolon? And notice, no, there's not. Now there is. Now there's not. So the way that the match method is going to work with the regular expression class or object is that it's going to return true for this because there is a semicolon. It will return false for that because there is not a semicolon. Let's see. Some of the other items you can have is XP underscore. But if I take any of those out, it's expecting exactly that sequence of characters like that, XP underscore. You can't have a single quote. You can't have a double quote. So all of these characters are coming up multiple times highlighted if there is a match. Anything else? Oh, so just star, asterisk by itself doesn't, but backslash asterisk, yes it does. So that is giving me the pattern. I feel pretty confident that this is the pattern that I want. Save that pattern once you get it because we're going to use it in our code for our application that we're going to develop.